So with this, when we have triangles like this, okay, anytime we have triangles, you have, like, here's your checklist. I want you to write this checklist down, right? And this is the order in which you're checking things, right? You're always going 90 degrees, question mark. Is there a 90 degree, right? It's the first question you're going to ask, right? I don't see one in this triangle, right? But if I see 90 degrees, that leads me to go, okay, I'm going to use SOHCAHTOA, or I can use a squared plus b squared equals c squared. Okay? If I see a 90, and only if I see a 90. Okay? If I don't see a 90 degree, and by a 90 I mean, is there something with a little square in the corner? That's a 90 degree right angle. Then the second thing you're going to want to check, and I'm just going through the list of simplicity, right? The next thing you're going to want to check is, can I use sine law? Right? So you remember sine law looked like this. Okay? Or you could flip them. Okay, they could be the opposite way too, but it doesn't matter. What you can't do is start mixing. You can't flip these around with, like, they all have, like, all the signs have to be on the top or the bottom, and all the letters have to be on the top or the bottom, right? You can't flip them around. Okay? So that's the second easiest. And then the third one is the one we looked at yesterday, or on Friday, sorry. It was cosine law. Okay, and I'll show you something. Yes? It doesn't matter. It just depends on how, like, so depending on how it got shown, right? Mr. Sador showed you that these were like the little letters. I've always kind of seen the angles as capitals, and then the side lengths would be the little letters. But it doesn't matter, right? Okay. So cosine law looked a little bit like a squared is equal to b squared plus c squared. So Mr. Sador said it was like this Pythagorean theorem, but it's not, right? And then minus 2bc cosine a. Okay, we'll do a whole bunch of cosine law today on top of some sine law. Just review sine law. You do not want to do cosine law. You want to avoid it wherever you can. It's the most complicated one, right? So this is the series in which you're checking. Is there a 90 degree? You're happy if you see a 90 degree because those are the easy questions. If you don't see a 90, you're checking for sine law, which I'll show you how to identify something, sine law versus cosine law. This is the last resort. Cosine law always works, but it's the most complicated, right? I want to avoid using cosine law. Okay, it's more work. Okay, so let's look at the first question. Okay, so I labeled the triangle. I got capitals for the angles, and I've got little letters for the side lengths. Okay, do I see any 90 degrees in there? I cannot use SOHCAHTOA or a squared plus b squared equals c squared because there's no 90 degree. Let's go to the second one. Let's write down the stuff I know. Let's just do that. Okay. I know angle C. It's equal to 41. I know side length C. It's equal to 12.2 centimeters. I know side length A. 17.9, right? But the question is asking me to figure out what this angle is, obviously, right? So I want to know what angle A is. So I have something in my tool belt that allows me to solve for angle A, right? Let's just jump over here for a sec, okay? I'll highlight this. Angle C Okay, I'll highlight these so that you know where they go. Angle C is 41 degrees. I can put that right here inside the sine, right? And then I have side length C. I can put that underneath, right? And then I have side length A. Well, that can go over here. And what's the last thing that I'm looking for? Angle A. So what I have, if you look at sine law, you can ignore the middle here because it's not asking me about B, right? It's only asking me about A. And the only way you can do anything is if you have if there's 4 things here, I need to know 3 of them in order to find the 4th, right? So in this question, I have 1, 2, 3, 4 things, but I also know 3 of them, right? The only one I don't know is A, which is what the question is asking me to solve for, right? So I'm just going to rewrite sine law with whatever side lengths I have. So I'm going to go, okay, sine of A over A is equal to sine of C over C. And then I'm just going to fill in the information that I know. Right? So sine of A, I don't know what A is, over 17.9 is equal to the sine of C, which is the sine of 41, right, divided by 12.2. Do we have any questions? Are we okay? See where all that stuff went? Okay, next step. You could do this next step if you want, or like right now, or you can do it after. I just like getting rid of the stuff that has sine in it, right? So I see the sine of 41, right? The sine of 41, if I go over to my trig table, okay, I'm looking for the column that has so. And what you're going to do is go find the angle 41 on the left, and then you're going to read across and tell me what the decimal is for sine 41, or type it into your calculator, right? I like the trig table because it's kind of handy. So that if I look over at 41 degrees and I go over to the so column, I should see 0.6561, right? So that number is going to go right there. It's going to replace all of sine. So I'm going to rewrite this thing, right? Sine of A over 17.9 is equal to 0.6561 over 12.2. Okay? Work's almost done. Okay, we have this thing called cross multiplication. Okay, that basically gets rid of the fractions. There will be no more fractions in the next line. The way it works is I go like this. I multiply this by that, and I multiply this by this. And your next statement is 12.2 multiplied by sine of A is equal to 17.9 multiplied by 0.6561. It's a calculator exercise now. Okay, what's the next step? What am I trying to do? Remember what I'm trying to solve for, right? Right from the very beginning, we said this is what I'm trying to solve for, right? I don't know what this is. So I'm trying to get it by itself so that I can read it off with my calculator. That's what I'm trying to do, right? So I'm just trying to get the yellow piece by itself. So the last step here is just to go, okay, well, if I want this by itself, then I can move this to the other side if I divide it, right? So if I divide both sides by 12.2, all right, the 12.2's will now cancel, and here's something. I can just type this all into my calculator and get an answer for what sine of A is. Okay, so I just need a number, right? So I'm gonna have sine of A is equal to a number, whatever the number is. Somebody's got to do that in the calculator. Okay, so what I'm gonna do is go, okay. Most of us like using our phones, so I'm just gonna go 17.9 multiplied by 0.6561, hit equals, divide, you should have 11, you should get something like 11.79 in the top, 74 in the top, then you're going to divide that by 12.2, right? So that's going to be equal to 0.96626, right? And then angle A, you have to go find this decimal in the sine column. Okay? So I'm going to go 0.99626 is pretty close to 74 degrees. Okay, can we see that? If I go, oh, my calculator. Oh, I don't have a calculator. I don't know why I don't have my calculator. You're going to have to, so if you don't like the table, okay, if you get to this stage here, you have this decimal. On your calculator, once you have it sideways where you would normally hit sine, if you hit the second in the top left corner, right? If you hit the second, that changes. You will then see where sine was, you will see this. Right? If you hit that button, so you would type in 0.9626, hit second function, that'll give you the angle. Okay? Trig table is nice because you don't have to worry about when do I use second function, when do I use, like, you just go to the table and do your thing, right? That's it. I like the table for that. Okay? But that should be your answer. Any questions? Remember, that's it's the easier of the two, I would say, right? If you do enough of these, it's just like it's just sine law, right? I like sine law, and you just use it. Cosine law gets a bit messy, right? I know I can use sine law when I see this, okay? If I see two things across from one another, anywhere, I can use sine law. If, like what you'll see in the next question, you don't see two things across from another, like two known things, then you can't use sine law. You'll see in a sec. Okay, is there any questions? Okay, so if I scroll down here, get rid of this. All right, so we want to draw that triangle. You can label this, how about we just stay consistent? This is my bad. I copied this question from somewhere. Why don't we just stay consistent and say that's A instead of X, okay? That way we don't confuse up. We don't make any like weird confusions with cosine law. Yes? Yeah, you want me to zoom in? Is that better? Okay. So, this is my favorite. Okay, so if you look at this and you remember this, you'll know when to use cosine law versus sine law. Okay. We call this, okay. What color is coleslaw? The food. What color is coleslaw? What color is it? It's green. Okay. I'm going to make a Are you watching? This is like, I remember had this being said to me in like grade 10. I'm going to make a coleslaw sandwich. You got two side lengths, right? And you got some coleslaw in the middle. Are you ever going to forget it now? No chance. No. If you see a, so we call this a side angle side, or the contained angle, right? So here's your contained angle right here, right? It's in between two side lengths. I know I have to use coleslaw. You cannot use sine law for this question if you see this. I also know I can't use coleslaw because, what did I say earlier? Is there any combination across from one another that you know two things? No. I'm missing the angle here, I'm missing the angle here, and I'm missing the side length for this one. That's how I know I can use sine or cosine law. I have to. Right? You see this contained angle. Okay? So, what are the versions of cosine law then? Do we know? What did it ask me to solve? Determine x. So I just got to find A. Or A. Okay? So, it doesn't matter how you label this. The only thing that matters is that you don't do this. That doesn't make any sense. You can't do that. Right? You can do this though. Right? It actually makes no difference how you label the side lengths and the angles. Right? So again, all the angles are capital letters, and then the side lengths are little letters. Okay. Now, 3 forms. And this is how I memorize this, and I'll give you these, so it doesn't make that much of a difference. Okay. So, a squared is equal to b squared plus c squared. Okay. ABC minus 2bc cosine A. Okay, here's how I memorize this. The A's contain the whole thing, and then the BC's go in the middle, right? And so if I were to write a different version of this, right? If I were to write it b squared, a squared plus c squared minus 2ab, sorry, ac, cosine b. Again, the b's are containing everything, okay? The third one, c squared, I would say a squared plus b squared minus 2ab cosine C. Everybody see what I'm getting? See the pattern? Okay, whatever letter you start with, right? It's like they're opposites, right? So the side length A and angle A contain themselves on either end of cosine law. Cosine law. Keep calling it cos law now. Okay. And then in the middle, you just put the two remaining ones with the two like the 2AC or 2AB or whatever, right? That's it. So in this question, I just want to solve for the side length, right? So I can show you the rearrangement for the angles after, okay? But it's just all you're doing is moving stuff over to the other side of the equal sign to get this by itself. That's all that's happening. So if you know these, you can rearrange these to get the angles if you'd like. Okay, I'll do one after. But let's actually solve this question now. So let's solve for side length A, right? And all you're doing, let's step one. Here's what I would do. Okay, every time I would make a list of knowns. This makes this question really easy because then you just plug stuff in. It's a calculator exercise. So again, it doesn't matter how you label these triangles. It doesn't matter. What matters is how you plug stuff in afterward, right? So let's say I'm just going to draw everything I know from the picture into a list. And then I'm going to take the stuff from the list and plug it into the equation and type it in my calculator and be done. That's it. So step one is let's write all the stuff. Angle A, 77 degrees. Okay. B, so side length B is 4.6 meters. C, 6.3 meters. And side length A, which is what I want to know, unknown. Right? How many things do you see in cosine law? How many things is there possible to solve for? I see one for the side length A. I see 2 for side length B. I see 3 for side length C. This is the same. That's also the same. Here's the fourth one. The angle. So there's 4 things. I have to know 3 of them. 1, 2, 3, 4. I know 3 of them. I'll just plug them into the equation, type it in your calculator, and get an answer. That's it. Let's practice. Okay? So, let's do the first. Which one? I need A, so I'm going to pick this one. Right? Because I need A. So I don't even have to do any arranging. I'm just going to start plugging stuff in. So it's A squared is equal to B squared is 4.6 squared plus C is 6.3 squared minus 2 multiplied by 4.6 times 2.3 cosine. What's the angle? 77. How easy that is. You're just going to sit there and type stuff in, right? What's 4.6 squared? Do we know what that means? It's the same thing as saying 4.6 times 4.6. What is that? $21.16. There you get that. Plus 6.3 times 6.3, 39.69 minus 2 times 4.6 times, why did I write 2.3? What's wrong with me? $6.3. $57 0.96, and that's attached to the cosine. What's the cosine of 77? Go to your table. You're under that column, right? The cosine column. You're going to go find 77 degrees and then read the decimal off. 0.2250. So it's 57, and this is attached with multiplication. Okay? Then you just start doing the math. 21.96. Sorry. 21.16. Okay, I get 60.85 minus, you got to do this, that times that. 57.96 times 0.2250. Am I done? What's wrong with that answer? Why does it look so much bigger than the other ones? This is only 4.6 and that's 6.3. Why is it so much bigger? I got to square root it, right? Here's the squared sitting here. What's the opposite of squaring? Square root. So square root on your calculator. Right? Give me a number for A. A is equal to? Alright, that sounds good, right? Does it make sense? Does it look like visually it's the longest side in the picture? It looks like it's the longest side, so then you know you're good. Okay? You good? So those are your two situations, right? The only way I can make this more complicated is if I ask you for now. If from the beginning I asked you for an angle, which would be a different question. I'll show you that when it comes up. Maybe it'll come up today. I don't know when these list of questions, okay? Now, what I have for you, we're going to take a little break here from the recording.